Okay, section 3.1, exponential functions and their graphs. You did exponential functions in integrated 3, but we did not make you plot this many points. They were sketches in integrated 3. We will now be graphing them, so we do expect to see a lot of completely accurate points, especially in the table, even if it can't be sketched perfectly on paper. So we will always graph from -2 to +2 for exponential functions. Those will be the numbers we start with for f of x. And over here it shows you how it works. 2 to the -2 is 1 over 4 because a negative exponent makes it 1 over, and 2 squared is 2. Negative exponents make it 1 over, 1/2. The rest of them, anything to the 0 is always 1, 2 to the 1, and 2 squared. Same thing for 3. 3 to the -2, notice the x's we plug in will be the same. 1 over 3 squared is 9. 3 to the -1, 1/3. 1, 3, 9. You could do it with 4. Let's do that really quick. You could do it with any number, so expect us to be able to do this with any number. If I was doing 4, always these numbers for x. 4 to the -2 is 1 over 4 squared is 16. 4 to the -1, 1 over 4. Anything to the 0, 1. 4 squared is 16. Then we will be doing our transformations. Our general form or our graphing form is written down here, and A, B, C, and D do exactly what they did before as far as stretch, compress, left, right, up, down, all of that stuff from the front of this chapter, from the transformations page of this chapter, I should say. So we will start with an example on my next page. So notice that it is in graphing form, but you don't see B right now. So I'm going to write it so that we see everything we need to see. -2 times, this 2 is just the base. That is not doing anything as far as transformations go. To the bracket, there's an imaginary 1 times x minus 1, and then +3 on the ground. So if I'm using the same colors as I did for transformations, -2 is A, that was yellow, B is that imaginary 1, C is in the parentheses, x minus 1, and D is the x plus 3 at the end. And remember, we have our formula, x over b plus or minus c, ay plus d. So for this equation, this transformation, I should say, of our parent graph 2 to the x, it's going to be x divided by 1, which I wouldn't even normally write, so I'm not going to write that. So it'll just be x, and then opposite, so +1 for the green, x over b plus c. And then for the y values, it'll be -2 times every y plus 3. Just like for our other transformations. A, y, plus d. So what we need to do is we need to start with a table of the original. We will not give you that for this one. So original 2 to the x, y equals 2 to the x, would be these points. -2 to +2. 2 to the -2 is 1 over 4. 2 to the -1 is 1 over 2. I'm literally getting it straight from this table right here. It's just that that table is not going to be given to you every time. Anything to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. These are our originals. This is where we're going to do that math that we just wrote down. And then we will get, they called it H. I guess these lines are a little longer than needed, huh? So we will take every x and add 1. I don't even need to write that in the middle. I'll write it once. This x plus 1. This x plus 1, all the way down. -2 plus 1, -1 plus 1, 0 plus 1, 1 plus 1, 2 plus 1. These will be our new x values. And now we will do what y says, -2 times the given y plus 3. You're always welcome to do a little bit of scratch work on the side. This is -2 over 4 plus 3, which is -1/2 plus 3. 3 minus 1/2 is 2 1/2. Sometimes mixed numbers are easier. -2 times 1/2 plus 3. -2 times 1/2 is -1 plus 3 is 2. -2 times 1 plus 3. -2 plus 3 is 1. -2 times 2 plus 3. -4 plus 3 is -1. -2 times 4 plus 3. -8 plus 3 is -5. These are our new points. Remember, they represent points even though I don't draw the parenthesis every time. Here's the other thing we want to talk about for exponentials. Well, let's graph this one and then we'll talk about it. So we have set up some axes with some graph paper with some tick marks on yours is what I mean, because I am on graph paper. -1, 2.5. 0, 2. 1, 1. 2, -1. 3, -5. These are the points I need to see. But what you should remember, hopefully from integrated 3, I'm going to go back to this page to write it down, is that the asymptote is always going to be at y equals d. The asymptote for exponentials will always be at y equals d. So if you go back over here, remember our d in this equation was 3, and actually this is going to be an answer blank on your tests. Asymptote. It's going to be y equals 3 for this one, because the d value is 3, which is why these points seem to be getting really, really close to, but not touching 3. That's why every other number is a whole number, but then it goes 2, 2.5. It would just keep getting smaller, smaller fraction, and never touching the y value of 3. And this exponential is hugging that asymptote and then curving down through these points. This is our graph. We also need, so asymptote I just told you will be an answer blank, y equals 3. We also need domain, range, intercepts, and transformations. So domain, range, intercepts, and transformations. So let's just do domain and range first. Domain, this is going left and right forever. The arrows go left and right forever. It's all real numbers. Range, my graph has an arrow going down to -infinity, parentheses, -infinity, and then it gets really, really close to that asymptote, so 3, but with a parenthesis. And these will always match, and they come from the orange number d in our equation with a parentheses. Intercepts, the y-intercept showed up in my table, so that's nice. So y-intercept is 0, 3. Oops. And then for x-intercept, we're going to need to do a little more math because I see it's going to be a decimal. So x-intercept, you always plug in 0 for y. Just into my equation. Start getting the 2 to the x alone, minus the 3. Divide by -2. Then remember, the only way to get an exponent out of the air, a variable exponent out of the air, is to change it to a log problem. So the base is 2, so that means it's log base 2 of 3/2 equals the exponent, equals x minus 1. Finish solving, add the 1. We will do, it's x, sorry. We will do more practice of this in class. Log 2 of 3/2 plus 1. So my x-intercept, even though it's a mess without a calculator, that's as far as you can go, it's the point log base 2 of 3/2 plus 1 comma 0. The final thing you might be asked is to find the transformations. I'm going to put my transformations in orange over here on the side. So a value was negative, that's reflect vertically. The a value itself was 2, that's stretch vertically. The b value was 1, that doesn't do anything. X minus 1 moved it right 1, and plus 3 moved it up 3. Okay, number 2, notice it's not in graphing form yet. So we need to factor out that b value. Remember, 3 is just the base, that is not part of the transformation. It's supposed to be bracket a single positive x, and then the minus 1 back down here. So the 1/2 needs to be factored out. Practice factoring out a fraction. Remember, when you redistribute it, you're supposed to get 1. So 1/2 times what would give you 1? It must be plus 2. So now you can see your A's, H's, and K's. Let's make our table. I'm going to make the table over here. We're going to have our y equals 3 to the x here. We'll come up with those together in a second. And then what are you going to do in order to find your new equation? So it's x over b. Remember, it's always kind of opposite what's happening. So if right here they are multiplying by a half, the opposite of that is dividing by a half, but that really just turns out to be multiplying by 2, right? The opposite of taking half of something is doubling it. 2x, and then it says plus 2, so we have to minus 2. That'll give us our x's, and then 4y minus 1 will give us our y's. Make the table a little longer, and we'll get our new points, h of x. What x and y values are you going to start with? What's the parent graph? It's 3 to the x. So remember, -2, -1, 0, 1, 2 every time. See if you can come up with their y values. 3 to the -2, 1 over 3 squared is 9. 3 to the -1, 1 over 3. Anything to the 0, 1, 3, and 9. So take each x value, double it, and subtract 2. So 2 times this x value minus 2. 2 times this x value minus 2. All the way down. If you can do it in your head, you don't have to show the work. -4 minus 2. -2 minus 2, 0 minus 2, 2 minus 2, 4 minus 2. Okay, then do the y's. 4 times this y minus 1. 4 times this y minus 1. -1, so 4/9 minus 1. So 4/9 minus 1, 4/9 minus 9/9, -5/9. 4/3 minus 1, 1/3. 4 minus 1, 12 minus 1, and 36 minus 1. We're not going to graph this one because clearly these numbers get really big really quick, but we will get a pretty good sketch and answer all the answer blanks as well. So let's get our answer blanks. Asymptote, domain, range, and then we'll sketch it and see if we can find any intercepts. Domain for all exponential equations is all real numbers. I skipped right over asymptote. The asymptote is always y equals the constant. So y equals -1 is the asymptote. So let's see what way this is going. This is going to be a terrible sketch. Oops. So we have -6, -509. Okay, so down a fraction. -4, a third. -2, 3. 0, 11. Then they get really, really high, really, really quick. But this makes sense because our asymptote, which needs to be graphed, I don't remember if I said that on the last one. Make sure you are graphing your asymptote. Our asymptote's at y equals -1, and it curves down and hugs it. So our range starts at -1, really, really close to it, so parentheses -1 to infinity. Now we're going to find our intercepts, which I need more space for, so I wrote the original equation over here. So, I don't know, x-intercept. You always make y equals 0. Start solving for the 3 to the x. Get that alone is what I'm trying to say. Divide by 4. The only way to get a variable exponent out of the air is to change it to a log. The base is 3, so it's log base 3 of the other side of 1/4 equals the exponent, 1/2 x plus 1. You're going to get a crazy looking equation. Minus the 1, and you can't actually minus it. It just looks like this. Multiply by 2, 2 log 3 of 1/4. Distribute the 2, minus 2 equals x. My x-intercept is 2 log 3 of 1/4 minus 2, comma 0, because an x-intercept is a point. Y-intercept, make x equal 0. Y equals 4 times 3 to the 0 plus 1 is just 3 to the 1. So this is, what am I doing? This was in my table. I didn't graph it because it was too big, but it showed up in my table. So at least we know we got it right. 0, 11 is our y-intercept. Okay, we will practice this more together in class. I hope you're doing well.